Hello everyone, nice to meet you. And in today's class, we introduce how to design a virtualized campus network for the large and medium-sized campus network. And today, we will introduce how to deploy the virtualized campus network. And today's course is separate in two parts. The first part is go briefly about the whole process, about the deployment. And the second part, we will show you an experiment just based on the MSNC controller to do the deployment. Okay, so let's go to the first part. Different from the traditional campus network that focus on the standalone devices, and the virtualized campus network focus on the overall service experience of the entire network and use the campus controller and with the VXLAN technology to flexible schedule the network resources. So this course we will introduce how to use the we will introduce the whole process for how to use the controller to deploy to manage the whole campus network, and how to deploy the services on the controller and deliver the configurations automatically to the whole devices. So first is some network plan and overview about the deployment. We have introduced last day. There are three deployment modes for the campus solution, such as the on-premise, the Huawei public cloud, and MSTP owned cloud. And for the large and medium-sized scenario campus network, we suggest you just buy the controller, buy the analyzer, and install them in your own data center. Just choose the first one, on-premise scenario. And this is the whole virtualized campus network architecture we just introduced yesterday. We separate the whole network as three layers. The physical network layer, who just achieve the interconnection between the physical devices, and over it we just create the network resource pool, and we call this resource pool as a fabric layer. And the fabric layer is based on the VXLAN technology to make all the physical resources as the resource pool, and then it can be invoked by the different VNs. We can create different VNs to support different services, and for different VNs, they are isolated with each other. And this is the network node on the virtualized campus network, and for the fabric domain, for the VXLAN domain, there are two important nodes. They are the edge node and the bottom node. And for these two nodes, both of them need to support the VXLAN. And for other nodes, they do not need to support the VXLAN, such as the transparent node between the edge and the bottom node. And if you separate, you just deploying the VXLAN across from the core to the aggregation. That means the edge node is now the access layers node, so that will have the access node to connect with the terminals. And between these, so in this scenario, you can use the policy association to do the authentication process. And for next part, our experiment, we will use this topology. This is our lab topology. There are 1, 2, 3, 4, 5 switches with an AR as the external of this network, and we also have an AP to provide the SSID for the wireless users to access to our network. So for this experiment, there are a lot of requirements such as this. the first network devices support DHCP-based plug-and-play provisioning. And in our experiment, we use the AR3 to do as the DHCP server. And it is the DHCP for the devices to plug and play, and is also the DHCP server for the wild users to get the IP address, and then they can connect to the network resources. And next is multiple services on the campus network share the same physical network, but are logically isolated. Mutual access control can be implemented among these services. That means you need to create several VNs for different services, and for the VNs, they just established over the physical network, just like this. And the third service configuration is automatic, and virtual network configuration are delivered by the controller. That means all of the devices need to be managed by the controller. And that means on the controller, you will find all of the switches and APs will go online on the controller. And then you just do some deployment and do the services planning on the controller, and the controller will just deliver the configurations to the devices automatically by using the netconf technology. And the last requirement is users can access virtual network from anywhere on the campus network. That means you use the free mobility. So for the users, they just use the user account with the username and password. They can just pass through the authentication process, and then they will get the authorized rights, and they can access to the specific network. So this is the requirement we will meet in our experiment. And as well as we use the fit AP with the AC architecture of the double-line. So in this experiment, we use a native AC on the border to manage the APs, just to manage the double-line services. Okay, and after you have established you have designed what is the specific topology, and then for the virtualized network, you need to think about what kind of gateway solution you need to select. And for there are two gateway solution. One is for the centralized, another is distributed. The difference is where is the layer 3 gateway located on. For the centralized, the gateway is on the border. For the distributed, the gateway is on the edge node. And both of the gateway is just for the wild users. And for the wireless users, the gateway is on the border because we use the border worked as the native AC, right? And you just determine based on the size of the network, you can think about what is the solution you need to select it. And in our experiment, we use the second one, just use the distributed gateway solution as the example. So after you think about after you choose the gateway, you will think about what is the VXLAN domain across from the what is the VXLAN domain scope. And in our experiment, we just deploy the VXLAN across from the aggregation layer to the core layer. So this part is the VXLAN domain, and for these two access devices, they just access node for the network. So let's check the experiment network part to part. The first part is the HQ. It's just our campus network, and the HQ the two access devices is connected to the web terminals, and for the ACC2 is connected to an AP, and for the AP it's just provide SSID for the wireless users to access to. And then is for the aggregation layers devices. There are two aggregation layers. They are the edge 1 and edge 2. And these two devices, we regard them as the edge node of the fabric domain or of the VXLAN domain. And for the core layer, we regard it as the border node of the VXLAN domain. And then it's the AR3. We use the AR3 to do as the egress devices to connect to the external, to connect to the cloud. And the AR3 is also simulated as the external network by using some VLAN interface to simulate the external network or to simulate the network services resources such as the DHCP server to the fabric network. So before you manage the whole switches by the controller, you need to do some pre-configurations on the AR3. And the second part is the cloud, and we use the AR servers SW. We use these switches to connect between the HQ with the controller, and it's also function as the gateway of the controller. And then it's about the VXLAN domain. We just introduced it. It's just deploy across from the aggregation to the core layer, and we use the distributed gateway. That means the wild user gateway is on the edge 1 and on the edge 2. And in this experiment, we use the border as the native AC. That means we use the border node to it's also function as the DHCP server to allocate the IP address to the APs. So the APs need to establish the capital IP terminal with the native AC, and it will get the IP address from the AC, and then the AP will go online, right? So this is the whole topology about our experiment. And in our experiment, we need to separate some VNs to isolate the services, and we just create two VNs. One is for OA, another is RD. And the OA, there is 4 kinds of users can access to the first VN. They are the sales wild users, sales wireless users, and the market wild users and the marketing wireless users. And for the RD users, it can only connect to the RD VNs. So we isolate these two groups of users by create different VNs. And for the VN, they can connect to some external network. For the OA VNs, they can only connect to the OA external network. And for the RD VNs, they can connect to the RD external network. So you need to create 2 external networks for the VN to access to. And for the network service resources, we just create one of it. The name is DHCP and email, and we just use the AR3 to simulate the DHCP and email server by creating some IP address on the AR3. And for this network service resources, it can be accessed both for the RDVN's user and OAVN's user. And because we have 5 kinds of users for the sales wireless, market wireless, and RD, so we need to create the dynamic security group for them to authorize this security group after they pass the authentication. So these 5 are dynamic security group. And for the email, or for the DHCP server, or for the email server, we need to create a resource group. Or you can also create a static security group. It's okay. But in in this time we create a resource group because we create a resource group because we only use it to become the destination group on the policy control matrix. So this is for the security group creation. And after you create them, we need to deploy the, we need to design and plan the policy control matrix based on the security group. And we put the, put this those dynamic security groups on the source group, and also put them on the destination group, and put the services resource group to the destination group. And then you can, based on this planning table, to deploy the policy control matrix on the controller. So for design, that means these two groups cannot connect with each other. And by default, the action is permit. So if you do not do any configuration on the matrix, that means these two groups can connect with each other. Okay, this is the requirement and planning, requirement and planning of the of here. Okay, and someone asked. Okay, someone asked me, what is the OA mean? The OA is just means the office automation, just means the office users. So we use the OA in short to regard as the users on the office. So as usual, the OS users is always explore ins on our network. We just use it as an example, and the RD is just sorry, wait a moment. And the RD is just determined to the research and development. So we use the RD in short to determine it as the research and development employees who can access to this kind of network. So it's just an example. It's and in our experiment we create the OA VNs for the sales and market users to access to this kind of network. Okay. And then is just the briefly process for us to deploy the virtualized campus network by the controller. First is the deployment process. This is the whole process for how to deploy the virtualized campus network based on the cloud campus solution. For the first step, you just need to establish your topology based on the physical devices, and you need to install the servers, install the controller, or if you need the analyzer, you also need to install the MSNC campus insight and power on all of the devices. And in this slide, we only start on this step. Just when you have power on all of the devices and you have already installed the controller, and on the controller we need to create the sites and then manage all of the devices and do the deployment on the controller. So we will just go through the blue steps on this slide. And then it's about the preparation for the deployment. First, you need to install the server and the software we just mentioned for the controller or for the campus insight. And if you need to think about how to establish the double LAN network, you can also download the Cloud Campus app by your mobile phone, and with this app you can easy to to maintain the network of the WLAN, and it provides some special functions such as the Wi-Fi experience testing, the speed testing, and the video testing. And this is only for the WLAN network. And then it's also you need to do some pre-configuration for the AR3s, because the AR3s function as a lot of roles. For example, first you need to create the IP address, create some VLANs to make the interconnection between the HQ's network within the controller, right? And the second, it is the DHCP server. And it's the DHCP server for the whole devices. For the whole devices of the switches, they need to plug and play on the network. That means when they powered on, they can get the IP address, get the controller's IP and port number from the DHCP server, so they can go online and can go onboarded on the controller. And second is also for the wild users. It's also the DHCP server for the wild users who want to connect to the network. And third, we use it to simulate the external network and the network resource, network service resource. That for these two parts, we use them to be accessed by the different VNC users. So you need to do some pre-configuration on the AS just to provide these functions. This is the preparation for the deployment. And after that, we just use the controller to deploy the to manage all of the devices, and then to do the deployment. So first, you need to create the site, and a site is just like it's just like tonight, or just like a network that be managed by a specific department. So the site is very important on the site is very important on the controller, and the two sites are isolated with each other by default. And then you need, and after you create a site, you need to add all of the devices on the site, so the controller can manage them, and deploy the configurations to them. So the controller's deployment is based on the site. So the first step, you need to create the site. And there are two methods for you to create the site. First is creating the site one by one. If you only have several sites, you can, or just one site, you can just create them one by one by site the site name, and tell the site what is the device type you have. And in our experiment, we have the AR, we have the switches, and we also have the WAC, right? Because we use the border as the native AC. So if you choose the AC, you do not need to choose the AP, because if you choose the AC, that means you use the architecture with the fit AP and the AC. And if you only choose the AP, that means you use a cloud mode AP, single, just use the fat AP, okay? And then you need to add the devices to the site. And for the site, you for the devices, you also have two methods to add it. One is by model, just by the devices model like this, which is a series of the devices belong to. And also you can buy the ESN. The ESN is the identifier of each devices. So you can add the devices one by one just by this mode. And another method is to create the sites in a bench. That is, you can download a template from the controller. the control just like this. You can click it and download the template. And this template is just an Excel table. You can just enter the sign name, enter the device type, the device roles, and device models on it. And then you can just upload, just import this template to the controller. Here, click the upload, and then the controller will create this sites in bench. So there's two mode for you to create the sites. So for a small number of sites, you can just use the first one to create one by one. And for a larger number of sites, you need to edit. You can just use the second one. Just download the template and create the sites in your bench. And then this is our experiment. We will just introduce in the next part. You can just create in our experiment. We just create the site singly. That means you manually create a site and then and then you will add the devices by model or by ESN one by one to the controller. When these switches powered on, they will get the IP address, get the controller's IP address and port from the DHCP server, right? And then they will just register to the controller. When the controller adds these devices to it, it will just find all of these devices have gone online on the controller. So this is the first step for us, is to create the site and to manage the devices. And in this step, you can add the AP as well by using the model or using the ESN. But till now, the AP is not online on the controller because the AP is management by the AC, right? But now you are not deploy for the ACs. So after you deploy for the native ACs, the APs can go online. So in this time, the APs, you can add it or not add it. You can choose the double-line service to add APs. It's okay. Someone asked me, so the site is a site of devices, not only one device, right? That's right. A site is matched to such as a department's network, a group of devices that just be managed by a specific department. As usual, if in one experiment, in our experiment, we just set this part of just like our HQ. We just create a campus network, we call it HQ, and we just put all of these devices on one site, and the site name is HQ. That means you can just manage the HQ's devices, just be managed by the controller, and the controller can unify to manage and deploy the services for all of the devices. Someone asked another question: how can I identify if more sites are needed? You can just create the site on the controller, and the controller will separate the site by default. And one devices can only belong to one site. So if you have two sites for the HQ and branch 1, the site 1 is the HQ, the site 2 is the branch. And on the controller, you will also create two sites. And for the HQ, you have 5 devices. For the branches, you have another 4 devices, for example. And these devices, they are isolated with each other, and you will do the deployment isolated as well. And then after we create a site, and after we manage all of the devices, we need to do some deployment, right? Before we do the deployment, you need to plan some resource, deploy some resource for the controller to deploy the services automatically. And there are two resources pool. One is global resource pool for the fabric. That means if you want to create the fabric network, you need to get the resource such as the VLAN, the BD from this pool. And another resource pool is for the underlay automatic resource pool. It's used for the underlay network interconnection establishment. We will talk about it later. So the first resource pool is for the fabric. And in this resource pool, we will consider about the VLAN, the BD, and the VNI. And for the VLAN, it's just in this pool, the VLAN is used to connect to the external network and the network service resources. So they are the interconnection VLAN between the border to the external network. And also the VLAN we use to, and also consider about the VLAN for the users to access to, just the service VLAN. So this is the interconnection VLAN, this is the service VLAN. We will these two VLAN will be considered on the global resource pool. And another two resources is for the BD and the VNIs. If you want to establish the fabric, that means you will establish the VXLAN, right? For the VXLAN, for establish the VXLAN terminal, you need to consider about the BD, just the broadcast domain, and the VNI, just the identifier of different VXLAN, right? So these two parameters also need to be considered on this pool. So this is the page. This is the lab step. You need to enter the network planning page, and in this page there is a lot of resources you need to planning for the resource pool, for the post template, for the device resources. And for the device resources we have already think about it, such as the site design, just for create the different site. If you only has the HQ, if you only has one site of network need to be management, you just need to create one site for the controller. And if you have HQ and have several branches, that means you need to create several branches, several sites on the controller. And then is the device management, just for add the specific devices to the matched site and to control them. After that, you need to consider about the resource pool. The first is the fabric global resource pool. You need to think about the VLAN. The VLAN is for the interconnection VLAN, the transparent VLAN, also the access VLAN for the users. And you need to consider about the BD and the VNI. And for the BD and the VNI is just used to establish the VXLAN terminal. Second, you need to consider about the underlay automation resource pool, just for the underlay networks to deploy the network interconnection. So in this resource pool, you need to consider about the interconnection VLAN and interconnection IP addresses we used on the underlay network. And then it will automatically use the OSPF to deploy the underlay networks. So in this second resource pool is for the underlay automation resource pool. You need to consider about the interconnection VLAN. The interconnection VLAN is here. Is used for the devices to connect with each other, and also the interconnection IP address to connect with two devices. In this part you also need to consider about the loopback address, and the loopback address is used to establish the BGP EVPN. It's used to establish the BGP EVPN enable relationship. So if you enable the automatic routing domain configuration, that means you will deploy the OSPF on the underlay network automatically, as well as you will enable the BGP UVPN automatically, so it will establish the neighbor relationship automatically. And then you can see in this page, you need, for the network planning, you need also to think about the policy template for the authentication, and for the authentication. And for the authentication, you need to think about if you use the 802.1x authentication or the MAC address authentication, you will based on the radio server. So you need to create the radio server template. And for the portal authentication, you need to create the specific radio server template and also the portal server template. And for each of the authentication, you need to create the authentication profile, do remember, by manually configuration. So on the controller, you also need to create the authentication profile just by create the authentication template. Someone asked me, OSPF is used in this example, but ISS can be used, cannot it? In the controller, it can only use the OSPF. For the dynamic routing protocol, it can only use the OSPF to automatically deploy the underlay network. And you can also use the static route. If you want to connect to the external, want to connect to the branches, you can configure some specific static route is okay, but the ISS is not supported yet. Okay, so we have just mentioned you need to create the authentication template, the service template for the users to go through the authentication process. And in our experiment, our users, they are the wild users and the wireless users. And then for the wild users, we only use the 802.1x authentication. And for the wireless users, we will use the portal authentication. So on the controller, you need to create the radio server template, create the portal server template, also create these two kinds of authentication template for the authentication process. And this is the process for you how to create this template. We will not talk about detail about it. We will show you how to create it in the next experiment. And after you plan the resource for the network you can just create the fabric. When you create the fabric, you just need to you need to determine what is the edge node, what is the border node, and then you need to configure the underlay network automatically, and then you need to configure the external network, the network service resources that can be accessed by the VNs. And also you need to do the access management. That means you need to select what is the specific interface for the users to access to the network, because on the specific interface, you need to bind with the authentication template, right? To tell the devices what is the authentication you will do for the users. So all of this work you need to deploy on the fabric network step. So first, you just need to create a fabric, and this is the process for creating a fabric. You need to select the network type, select the AC location. Just for our border, in our experiment, we use the border as a native AC. That means you just choose the border node as the AC's location and enable the automatic routing domain configuration. That means you want to automatically configure the underlay network. by deploying the OSPF. And you need to configure the AS number and choose which devices is the RR. And as usual, we will choose the border as the RR to reduce the IBP relationship number. And you can also configure some other extension functions. So next page is tell us how to create the fabric. And this is our logic topology. And based on the topology, you need to create the fabric one step by one step. And first, you just tell the controller what is the fabric name. And our fabric name is just, we use the HQ as an example, just the same as the site. The site name is also the HQ. And for the network type is for the gateway, we just choose the distributed gateway in our experiment, right? And if you use the centralized, you can just choose the first one. And for the AC is located on the border. For the ACs, it's just located on the border. If you use the edge, you can also use the edge board as native AC or use the standalone AC, or if you do not deploy the double line, you can choose the none. And then you need to enable the automatic routing domain configuration to automatically configure the underlay network and set the AS number, set the R cluster ID. And then you need to add the devices on the fabric and then tell the controller what is the specific role for each devices. So for the border, its role is the border. For two edge nodes, the role is the edge. And for the two access devices, they address the extended switches for the fabric. Do you remember the fabric? The fabric have three kinds of connected type for the extended AP, extended switches, also the terminals, right? So the two ACC switches for the fabric network of the edge node, they are just the extended switches. And you just you enable the border to become as the RR. Because as usual, we use the border as RR to reduce the relationship of the IBGP. And then you need to do some basic configurations for the experiment. First is for the underlay network. When you enable this function, you can just choose use one single area or separate areas. Also, you can choose the network types, choose the encryption types, and then it will just deploy the OSPF on the network. So someone asked me, underlay is automatically configured based on IPv4, IPv6, or dual stack. In this, if you configure to all of you listen clearly of this question. The question is, if we enable this function, if only the IPv4 configuration will be delivered, or the IPv6 or the dual stack. If you want to configure the whole network by the step, just like I show you, it can only if you enable this function, it can only deploy the IPv4 configurations to the whole network, and for the IPv6 is another step. And for our controller, we can show you. Sorry, wait a moment. Okay, this is our controller, and for our controller, it's just to show you some basic some typical scenario for the branch network, multi-branch interconnection, and for the fabric network. And as usual, for our campus virtualized campus network, we will use the fabric network scenario. And if you choose this scenario to do the configuration. It's just a simple. It's just provide a simple step for you to deploy the network just based on this step. But if you have some special requirements, such as you want to deploy the IPv6, you need to go to the special page to do the configuration, and it's not on this page. And this page will only introduce if you use the fabric network scenario. This typically tools for you to deploy the network. Okay, and after you deploy the underlay network based on the OSPF, it's also, do you remember we choose the border as the RR, and we determine the AS number, the R cluster ID, and then the fabric, the controller will also do the BGP VPN basic configuration to the whole network automatically, and then they will just use the loopback address you have determined on the underlay resource pool. Do you remember? For the loopback address, you just use the loopback interface to establish the BGP VPN neighbor relationship. And till now, the fabric is created. After the fabric is created, the underlay network can be automatically deployed, and configurations such as the VLAN if interface, the loopback interface, and VTAP IP address, and the routes required for the establishing a BGP VPN can be automatically provisioned by the controller to all of the devices that the controller managed. And the controller allocated resources from the Fabric Global Resource Pool and the underlay automation resource pool, just you planned to the devices. So after you create the fabric, and then you need to consider some resources for the logic network, just for the VNs can use to for example, for the VNs to access to. So you need to create the external network, create the network service resources, also to do the management for the user's access. So first, you need to think about the external network. If you want to create the external network, you need to think about what is the mode you use to connect with the external network. And in our scenario, the gateway is just inside of the fabric, right? We use the distributed gateway solution. So the gateway is here. That means they are inside of the fabric. So you can only use the L3 exclusive egress or L3 shared egress. And if the gateway is outside the fabric, you can choose the last one just for the layer 2 shared egress. And in our experiment, we choose the second one. And then you need to create the external network's name. Create the external network's name, and it use the VLAN if interface to connect with the border to the external network. And you can use the static route or use the dynamic route for the border to connect to the external network. And in our experiment, we use the static route. And you can enable the internet connection. If you enable this function, that means you use a default route. You will deliver a default static route to the border to connect to the OA external network. And if you do not select this icon, that means you will use a specific prefix static route to connect with the border to the external network. So please pay attention to this function. And then after you configure the basic configuration, you need to configure the interconnection information. First, you need to select the devices who just connect to the external network. So in our experiment, as usual, we use the border to connect to the external network. And the external network is just simulated by the AR3. Do not forget it. And then you need to add the interconnection information, such as the border use which port to connect to it, and use which VLAN, use which interconnection VLAN, which interconnection IP address. So it's just like this. For the border, it's use the gigabit Ethernet 001 to connect to the external network, and the local IP address is this, the peer IP address is this, and it uses the VLAN 130. That means the border will create an interface VLAN. Interface VLAN if 130, and then for this VLAN if interface, it will assign the IP address with the 13.1.1.2, because the local IP address is like this. So for the pre-configuration of the AR3, you need to configure a VLAN interface 130 with the IP address of 13.1.1.1 in advance. So this is the pre-configuration for the AR3. And then you can just do the root configuration, because we enable the internet connection. Do you remember? So it will just deliver a default static route to the border. So for the border, it just use this default route to connect to the OA external network. However, after this step, the static route will not be delivered to the border. Only when you create the VN. For creating the VN, you will select the specific external network, such as the OA. And after the VN is created successfully, this route will then be delivered to the border. So this route will be delivered to the border after you create the VNs successfully. And then you need to, based on this step, to create another external network for RD. And the step is same, so we do not mention it again. And the next is for create the network service resources, just for the DHCP and for the next server, also for other servers such as the email. We used on our experiment. And for the network service resources, first you need to create the name of the resources group. And do you remember we just talked about yesterday? For each network service resources, it will create a specific VPN instance and will create a static route binding with the VPN instance to the network service resources. So the VIF is just used for the specific network service resources. And then you need to choose the server type. And in our experiment, we use the DHCP. We will use the DHCP server and the email server, for example, because it's only designed the DHCP, the radius, and the porter. And if you want to determine about other servers, you need to select the other. And for the DHCP server, you need to tell the controller what is the DHCP's IP address. And for the other servers, you can you need to configure the other server's IP address here. And if you want, it can only, in this experiment, we use the IPv4 server. And if you want to supply the IPv6 server, it's both okay. You can just configure the IPv6 server's address here. And for the IPv6 server, you need to configure the interconnection IPv6 address pool for the border. Just put the IPv6 address pool here for the interconnection between the border to the network service resources. And then is for the interconnection information about these two devices. First is choose the scenario. There are three scenarios. One is for directly connect to the server. That means the border's interface will change to an access port. And if you choose the directly connect to a switches, and the switches connect to the server, that means you just change this port as a trunk port. Because in our experiment, we use the AR3 to simulate the external network both as the network service resources, and all of them are passed through the one of the specific interface of the border. So it will transform a lot of traffics. We need this interface to become as a trunk interface. So the scenario here, we will choose the second one, just directly connect to switches, and then the switch will connect to the server. And then you need to tell the controller what is the interconnection information, such as the interconnection devices. We use the border to connect to the network service resources. And then the interconnection port is just this physical interface, just for the gigabit Ethernet 001, and the interconnection VLAN, and the interconnection IP address. So after this, you will create a VLAN if 152 with the IP address of 192.168.150.2, and then it will create a static route bind with the network service resources VIF and to the destination of the service IP address. So for the R3, you need to do the pre-configuration about to create the VLAN if 150 with the IP address of here. So after these two, you need to management access to the users access to the fabric. So you need to consider about what is the authentication point. The authentication point of the network, just bind the authentication template to this point. So you need to choose a specific interface to bind with the authentication template. And this process will do on configure the fabric. It just configure the access management. And for the fabric network, it has three kinds of connect type: the extended AP, the extended access switches, and is the tunnel. So for the edge node, it connects to the switches, and so its type is the extended access switches. And for the access switches, they just connect to the AP or to the tunnel. So you can just choose the terminal as the connected type. And then let's think about our experiment. For our experiment, the edge node is in the aggregation layer, and the access layer is just a normal access switches. And we want to do the authentication, and we want only the edge node can communicate with the radio server. They just for the edge node, between the edge node to the controller, they just exchange the identification informations. However, for the access devices, we want it to receive the authentication informations and do the traffic controller and authorize the security group the service VLANs to the users here. So we can, based on the policy association technology, just separate the authentication point as 2 points. One is the authentication control point, another is the authentication enforcement point. So on the controller, you need to configure these 2 points one by one. So first, for the H1, the authentication control point is the H1. For the H1, you need to tell it what is the management VLAN and the management IP address for these 2 points to establish the cap-up tunnel. And then you need to tell the controller associate with the H1 what is the authentication enforcement point associated with it. So you will choose the ACC1 as the enforcement point. And then the 24 port is connected to a terminal. So you will you will choose the gigabit Ethernet 0024 to connect with the terminals, and it will just inherit the authentication template of the control point, and the control point is just bind with the authentication template you have just created. Oh, it's just bind here. You can find for the control point, you just bind the 802.1x authentication template you have just created on the network planning. And also for the H2, you need to create the point association between these two devices and tell the devices what is the management VLAN, management IP address to establish the web tunnel. And for the edge port, it need to bind with the authentication template. And for the enforcement point, it will need to choose for the wild users connect interface, you need bind it with the terminal and inherit the authentication template. But for the APs, it needs to bind with the portal authentication template. And for the portal one, you need to bind on the AC devices, right? So in this step, it do not need to inherit the authentication template because you do not configure the AC yet. And after you create after you manage the access, such as the authentication point, that means you have finished the fabric network creation. And then you need to create the logic network just to create the VNs based on the resource pool just for the fabric. So for the VNs, you need to create the VNs. For different VNs, you need to invoke the external network that just the VN can access to. Also, the network service resources that the VNs can access to, for the DHCP, for the email. And also, you need to tell the VNs what is the specific users network segment can access to the specific VNs. So for the VN, for the logic network step, you need to consider about these three things. So this is step for you to create a virtual network. First, you need to create a VN, and we need to create two VNs in our experiment. One is for OA, another is RD. So for the OA, you just change the name to OA, and you need to tell the controller what is the user's gateway location. And in our experiment, the gateway is inside in the fabric. So you need to choose the first one. And for different VNs, that means you just create different VPN instances. That means you create different VRFs. So you can just tell the controller what is the specific VRF's name you want to use. And then you need to choose the external network and network service resources that these VNs can access to. And this is the OA external network you just created. And for the DHCP and email network service resources, you have also created on the fabric network step. And then you need to allocate the user's gateway, and there are two modes for you to select the user's gateway. One is for automatic allocation, another is manually specified. The difference is that for different users, they have the specific network segment you have planning in advance. And for the automatic, that you just you just create the specific users with a subnet segment, and will do not tell the controller what is the gateway, and it will just choose one IP address from the segment as the gateway. So this means automatic allocation, and you can manually choose one specific IP address as the gateway. That means manually specify the user's gateway. So in this step, you just tell for the OA. For the OA, there are 4 kinds of users can connect to the OA OS VN. They are the sales wireless, market wired, and market wireless users. And for the RD, when you create the RD VNs, there is only one user for the RD user, and with the network segment of this, and you can just manually specify the gateway of the user. And the DHCP mode is the DHCP relay, because do you remember we use the AR3? We use the AR3 as the DHCP server of the wild users to connect to the devices, and for the edge node, it's just the layer 3 gateway of the wild user, and it will create the VBDE interface, and it will enable the DHCP relay to allocate the IP address for the wild users. So the DHCP mode here is the DHCP relay. And for the users, they will get the for the users, how does the users match to the specific VLAN? Do you remember? We just introduced yesterday. It will based on the service VLAN. So here we just choose the dynamic VLAN. That means the users can only get the specific service VLAN when they pass the authentication, and they will get the authorized result, and it will tell the users what is the specific VLAN it belongs to. So this is the dynamic VLAN. And then you need to configure the wild users for the OA. And for the OA, for the wild users, it can only connect to the ACC1 and ACC2, these two interface. So you just choose the ACC1 and enable this specific interface. It can be authorize the service VLAN by dynamic, and also for the ACC2. And for the wireless users, we choose the border as AC. And as usual, we suggest you use the tunnel mode to do the traffic transform. So for the wireless users, it's just sent to the AP, and AP will send the traffic directly to the AC based on the CapWeb tunnel. And then the AC receives the traffic here. So for the wireless traffic, it can only get the service VLAN and match to the specific VN and enter to the VNs on the border devices. So for the wireless access, you need to choose the devices as the border as the wireless access devices. So till now, you have just created the VNs. After you create the VNs, you will find that you have finished the whole function or the whole configuration about the BGP EVPN, and you create some special VPN instance for the bind with different VNs to isolate the user service, and also you create the static route bind with the VRF of the VNs to connect to the external network, and also deliver the configuration about the user's authentication, such as the access profile, the authentication profile, and bind the authentication profile with the specific interface. The configuration delivered by the controller of the authentication is just the same as the manual configuration we just introduced yesterday. Okay, after, if you have the requirement for two security group in different VNs to communicate with each other, you need also consider about the communication between the VNs. And for the interconnection of the VNs, there are two modes. One is for the partial internetwork. Another is for the full interwork. That means if you choose the full, if you choose the full mode, that means all of the user's network segment belong to the OA VNs can connect with the network segment belong to the RD VNs. So this means full. For the partial, that means it's only several of the network segment between belong to the OA VNs can connect to the RD VNs network segment. And in our experiment, we only allow the market world users can connect with the RDs. So you need to consider about two policies. The first, for the policy control matrix, you need to permit the action between the source of the market world to the destination of the RD. Also, source of the RD security group to the destination of the market world security group. And second, you need to enable the interconnection between the two VNs just to deliver the route. Between the two VNs, just choose the partial interwork of the VNs interconnection. And the next part is about the service deployment. After you deploy all of the network, you need to think about the policy, just like I mentioned here. For this step, you just make these two VNs have the route to connect with each other. However, you need also to think about the policy control matrix based on the security group. So you need to create the security groups also for the resource groups. For the security groups, you can just create one by one by tell the name. And if you want to create the static security group, you need to bind the specific IP address with the security group. However, for these 5 kind of users, we use the dynamic security group. That means all of these users will get the security group only when they pass the authentication, and they will get the authorized result from the authorization information. And then you need to create the resource group for the email and for the DHCP. And because the resource group is just like a static security group, so you need to bind the service IP address one by one for the resource group. And then you need to create the policy control matrix. Before you create it, you need to choose what is the specific policy enforcement point. And then for the controller, after the controller deploying the policy control matrix, it will deliver the policy to all of the enforcement point. So you need to choose the enforcement point first. And then you just deploying the policy control matrix like this. Change the action to deny. That means two groups cannot connect with each other. And by default, the action is permit. And then you need to think about the authentication. In our experiment, we use two authentication. One is the 802.1x, another is the portal authentication. And for these two authentication, you need to create the user's account first, and then create the authentication rule, and then create the authorization result and authorization rules for the authorized VLAN and security groups and other informations to the users. And if you want to use the MAC address prioritized portal authentication, you need also to configure this optional function for the portal authentication. So first is to create the user group and account. Because we have three groups for the market users, for the sales users, also for the RDs. So you can just create different user groups, and then in each user groups you can create a specific user account. So we use the Chris, for example. This is the user's name, and this is its password, and it belongs to the RD. And for the ID users, it just goes through it's just wild. If it is the wild users, we can just choose the 802.1x authentication mode. And then you need to configure the authentication rules. However, on the controller, it has a default rule, such as it just supports the PP, the CHAP, the EAP, and a lot of authentication protocols. So by default, you just use the default authentication rules is enough. And then you need to consider about the authorization result. The result, it means when the users successfully go through the authentication, they will get the access rights, such as the ACL, the security group, or the VLANs. And in our experiment, we use the security group and the service VLANs because the VLANs is dynamic VLANs to authorize to the users. So we will use these two parameters to authorize to the users. And how does the users to match the authorization result? It's just based on the authorization rule. So you need to configure the authorization rule to match the result one by one. So for the ID result, you need to create a ID rules based just used for the user access authentication. And you can choose for the wild users or for the wireless users. And it just match the user group. It use the user group, or you can use the specific user account to match to the authorization rules. And then when it matched, it will just get the authorization result, and then it will get the security group and dynamic VLAN. And after here, you just have deployment the wild network of whole campus network. And the last part is how to deploy the double-LAN services. For the double-LAN, you need to go through the step. First, you need to make the AP to go online on the controller, and the second, you need to do the wireless service configuration on the controller, and the final is just deploy the wireless service configuration on the AC's white page. So first, you need to add the specific APs to the associate site based on you can use the ESN or use the device model to add it to the HQ site. And then you need associate the AP to the border device because the border is the native AC to manage the AP. And then you need to tell the border what is the management VLAN, what is the management IP address to establish the cap web tunnel with the AP. So this is the management VLAN, this is the management IP address, and this is the AP's, this is the AC's IP address. And we use the auto negotiation. That means the AC, and the AP mode is the fit AP. That means you use the AC with the fit AP mode, and they will automatically negotiate with the AP will automatically negotiate the information from the AC, and it will establish the web tunnel, and for the AP will get the IP address of the AC, get the IP address of the controller, so the AP will go online. And also you need to configure the PNP VLAN for the wireless users. Just through this method, and then the AP will finally go online. And after the AP go online, you can do some double-LAN services. First, you need such as the authentication, and for the authentication, you need to do for the controller first. First, you enter the wireless authentication page and to set what is the SSID, and choose the pusher page, the page pusher, and choose the authentication service protocol is for the portal server template you have just created, and also the Redis server template, the Redis template you have created on the network planning step. And then you need to choose the push page. As usual, we just use the username and password. Authentication mode is enough. And then you need to think about the security authentication policy and also the bypass policy, and select what is the specific devices to do the wireless authentication. We just choose the native AC, just the border. And finally, you can go to the borders device configuration page, just to the web page, just like this. Enter the web page, you can just do the double-line services such as configure the SSID profile, configure the security profile and bind authentication profile, and bind them with the VP profile. And finally, you need to bind the VP profile to the AP groups, and then it will deliver the double-line configurations to the AP, and then the AP will just provide the SSID for the wireless users to connect to our network. Okay, so this is the whole briefly process of how to use the controller to deploy a basic campus network. And the next part, another teacher will just show the experiment, the whole experiment based on our controller to you. Okay, and next there are two questions. First, what site creation method are supported by the controller? There are two methods. The first one is create the site one by one, and another is create the sites in bench by download the template and import the template to the controller. And the second question is, which of the following parameters can be entered in the Fabric global resource pool? For the global resource pool, we will consider about the interconnection VLAN and also the BD and the VNI for establish the VXLAN tunnel. And for the B, so the answer is ACD. And for the B is the lookback interface IP address. And this IP address we will consider on the underlay automation resource pool to establish the BGP EVPN neighbor relationship. Okay, this is the whole information about this slide. I think you have a basic memory about how to use the controller to deploy a campus network. Okay, do you have any questions? Someone asked me a question. It's very long. I will read it later, and I will ask you by the chat group. So if others people do not have the questions, this slide is finished. You can just take 10 minutes break, and after 10 minutes, another teacher will just show the experiment to you. Okay, thank you.